Let us start with the normalization in SQL. So what is normalization? So normalization is the process to eliminate data redundancy and your data integrity enhance data integrity in the table. So when we are creating a table in a database, in any database, we need to take care of this normalization. So it is a technique of eliminating the data redundancy. Now, what do you mean by redundancy? So if you look at the dictionary meaning of redundancy, redundancy is nothing but it is not needed. So the things which are not needed, we have to eliminate that, and you need to enhance your table. So that is nothing but your normalization. So there are multiple forms of normalization. So there are actually 5 forms. First is first normal form. It is also called as 1NF. Second normal form, it is also called as second NF. Then we have third NF, and then we have BCNF, that is called a boys code normal form, and then we have fifth and sixth NF also. But we will be discussing about first NF, second NF, third NF, and BCNF, that is boys code normal form. So when you are working as a SQL developer, when you want to store a table in a database, you need to take utmost care that your table should pass with all these normal forms. So you should not have any redundancy in your table. Redundancy is your table should not contain any data that is not needed. So in a simple and layman's language, you can call normalization is a technique. Normalization is a technique of organizing the data in database. So let me put this in a first line. So it is a technique of organizing the data in the database. Okay, database. So it is the process to eliminate the data redundancy and enhance the data integrity in the table. So if you look at like what does redundancy means, that is the data which is not needed, data which is not needed. So now you can ask me like what is the use of the normalization, like what are the problems. So if you look at the storage, so if your data is not normalized, you will have the disk space more, or there will be more wastage for your disk. So the space will be consumed more if your table is not in a normalized form. And if the data is, or if your table is not in the normalized form, it becomes difficult to handle. I will show you some examples, you will get a clear understanding on that. It becomes very difficult to handle the database. Okay, database, I mean, you cannot update, you cannot easily retrieve the data, and so on. And insertion and updation becomes very difficult. Insertion and updation becomes difficult as data is not normalized. So we will see what do I exactly mean. So for that, let me jump on to Excel to show you some examples. Let me take an example here. Suppose I have a student ID. So this is a student table. I have student ID, I have student name, and I have the student, those who have enrolled for the course. Okay, course, and their age, for example. Now student id is for example 100 and the name of the student is A. He has registered for both the courses. He has registered for SQL as well as he has registered for big data, and his age might be 21. Now student ID 101, the student name is B and the course he has registered for is only big data. His age might be 20. 102 C, and he has registered for SQL and Python. His age is 22 for example, and so on. Now you can see when I want to retrieve the data of these courses, or if I want to update something on this, so this table is not in a normalized form because you have multiple records in this column. So you can have one more example on this. Suppose if I have a mobile number here, so he might have a mobile number 123 comma 345. So if we have two mobile numbers, so you can see he can like two numbers cannot be placed in the same column. So this is your data redundancy, or this is not in a normalized form. Yeah, now what I'll do, wait a second, I'll do some changes quickly. Now you can see the data is normalized now. So you can see it is accepting the first normal form where your columns or your records are not in a multiple cell. Okay, so this is the first normal form. Coming to the second NF, that is second normal form. So the second normal form, the table should meet all the conditions, of first NF. So that is the first requirement of the second NF. So what is the requirement of the second NF? Second NF should pass all the requirement of the first NF. So what is first NF? So first NF is the data should be in each column should have a atomic value, or it should not have any multiple value. So the first criteria for the second NF is the table should meet all the conditions of the first NF. After that, there should be no partial dependency, partial dependency, dependencies of any of the column on the primary key, on the primary key. Okay, so now you know what is primary key, what is foreign key. We have seen all the details about the keys. We are not going in deep of that, so you can watch the recordings. You will understand what are the primary key and foreign key. So what does it mean? So if you look at the data here, you can see this is our data which has come after the first normal form. But if you look carefully here, how come the primary key can have a same value here? You can see 100 is repeating, 102 is also repeating. So what does second normal form says? If your column should possess a primary key, if you have a repeated value, you should create one more table and create a relationship between that as a primary key and the foreign key. So what does it mean? So now from this table, if I try to make a new column from this, okay, let me copy this. If I make a new column in this, and if I say course ID, okay, and I give a course ID as 100, and if I give 101 and sorry, let me give 1 2 and 2 year, 1 year, 3 year. Okay, so I have three courses: SQL and Python. Now let me create a new table here, new table that should contain the course ID and the course. Now what I can do here, I have taken a separate table here. So here the student can enroll to number of courses. The student ID 100 can refer to as many courses as he want. So he can register for 3 courses also. So what I'll do, I'll create a new separate table here that is called as a student table, and let me show you. So the name of the student is 100, student ID, the name is A, and 101 the name is B, and 102 the name is C. Now this becomes your primary key. You do not have any duplicates here and no null values here. And referring to this column, the student ID, you can refer to the student ID column in this table. So if you look at 100, so 100 has registered for the 2 courses, you can see here. Now you can remove this course table also, course column also from here. Instead of course column, you can insert a course ID here. Now if you look at in detail, so E is registered for course ID 1. So what is the course ID 1? Again, for the course ID 1, you can take a course table where you can have a primary key here, where 1 refers to SQL, 2 refers to big data, 3 refers to Python. So you can create a multiple tables from your single table and create a relationship between that. So that is about the second normal form. Let us take one more example for the second normal form. Suppose if I have employee ID and name. Suppose this is your table here. So we have employee ID, name, age, gender, department name, and department head, and the department location. So as it satisfies the first normal form where you do not have a multiple values inside one single column. So we have an all atomic values. So now let us see whether we have a second normal form also. So instead of having a single table, what a second normal form suggests, you can you can take this single table and create a multiple tables out of it and create a relationship between that. So now instead of this, what I'll do, I'll create one table here with these records like this. I'll copy it here, and here I write or introduce a new column that is called department ID, and in department ID I'll put department ID 1 or 100 and department ID 101. So now I'll refer the department table in a different way here. Okay, so in this table I'll introduce a department ID also here. Now this is my first table, that is your employee table, and this is my second table, that is your department table, and there is a relationship between these. So if you are checking the details about the employee ID 1 is department is 100. So if you ask me, hey, on what is the department of 100, what do you mean by 100? So 100 is for big data, the head is this C person, and the location is Delhi. So what is the advantage here? Now suppose there is a third employee who is coming here in the company. His name might be R and his age is 28. He is male, for example, and if he is joining big data, so just you need to enter 100. Now no need to update all these values here because we know what is 100, what is the name of the department, what is the head, and what is the location. But when you are considering as a first table, you need to update all the values here, all the columns here. So here we have only few columns, but just imagine if we are handling 30-40 columns, so we need to put 30-40 columns in all the fields. We have to put the records. but whereas this will eliminate your data redundancy. Now if the fourth person comes, is T for example, let us take a female here, and she is joining an Azure. Okay, so 101. Now no need to explain me what is the department 101. We know that it is Azure, its department, its location, and so on. Suppose the company is hiring for a new department. So I just had a new department here 102, and it is for example machine learning, and the head is M and the location is Pune. Now, if a new employee comes with a machine learning, like we are hiring 5 employees, for example, we are hiring 5 employees in machine learning. So no need to upgrade this table 5 times. Instead of that, just we need to upgrade only 5 times here. So we need to just say that these all are coming from 102 department. That 102 is, we know what does 102 is. Department is machine learning, M is your head, and it is from Pune. So this is how you can create a relationship between these two. So this is the relation between these two, a primary key and a foreign key between the department table and the employee table. So this is how the second normal form works. Let us see the next normal form, that is your third normal form. So the third normal form is again the first criteria. It should meet all the conditions of second normal form. Okay, second normal form. So now what is second normal form? Just now we have seen second normal form should meet all the conditions of the first normal form. First normal form is like we should have an all values in the column should have an atomic value. So this is the first criteria. This is the first criteria that it should meet all the conditions of the normal second normal form. And the second criteria is the third normal form does not contain columns that are not fully dependent upon the primary key. Okay, primary key. So let me explain you with an example here. Let me take a new cell here. Okay, suppose I have a table here. Let me copy the same table here to show you the details here. Yeah, so I have a column here. Okay, let me, yeah. So here I have a salary column and I have a gross salary column. Okay, let me get a new table, a new column again. Yeah, this is my bonus. This is my gross salary. Okay, so if salary is 10,000 for an intern, okay, just an example 20,000, and if the salary is 10,000, the bonus is 1,000. If the this is actually the bonus is actually 10%. Okay, it is 10% of your salary. So let me put a salary into, it is 10%. Okay, so you can find in this way. And if I talk about the gross salary, it is nothing but the sum of these two. Okay, salary plus bonus. Okay, so this will be your gross salary. So now we have created this table, but what does the third normal form says? Third normal form says that it should not contain any column that are fully dependent upon the primary key. So this salary column is completely depending on the primary key, that is okay. But when you look at this bonus, so can you tell me on which column this bonus is depending on? Yeah, so this bonus column is depending upon the salary, and your gross salary is also depending upon the salary column. So wherever you have find these type of columns where these are not fully depending on the primary key. You can see if I remove this, if I delete also, there is nothing changed in this because those two columns were depending upon the salary column, not on the primary column. So what does the third normal form says? When you have this type of data and when these columns are not completely depending on this primary key, you can either delete this. So delete means you can drop these two records, drop these two fields, because these are derived. You can derive it at any time. Later on you can also derive because the bonus is 10% of this and your gross salary is the sum of these two. You can derive it at any time. So you can either drop this or you can put that in a separate table here. So this is how you can pass the criteria of the third normal form. BCNF stands for Boyce Codd Normal Form. So this BCNF is nothing but, it is also called as 3.5 normal form. So this is a, you can call an updated version of the third normal form, or it is a superior version of the third normal form. It is superior version of third normal form. So these are the normal forms, and these are the, this is all about the normalization, guys. So I hope you enjoyed this video. If you like this, so please subscribe to my channel. Thank you for watching. Keep learning.